All right, we're looking at chapter 12, and we're just going to go through a test here of common things that have been wrong in some students here. So let me go through. This is a common problem that has happened here, just so real quickly here. So I'm going to go through the red ones here, right over here. Notice the answer is in the thousands here for question number 7. Take a look at this one first here. The regression equation was perfect here. It says how many murders in 1,000 arrests could be expected from a state that has 4.2 thousand. So notice real quick here that your X is also in thousands of automatic weapons. If that is true, then you're not going to put 4,200 in here. You're just going to put 4.2. 4.2 goes in for the X right here. It's going to be 4.2 times 0.87 plus 3.88, and you're going to get this answer right here. So the answer should have been 7.534, just to give you kind of like the work of it out. This is kind of what I did over here. So there it is, plug it in a 4.2 because X is already in thousands already. So add that in and you get yourself the answer. Same thing happens in B. Don't plug in 5.7 thousand, just plug in 5.7. And as it works out to give you the answer. So no problem there. It was just a quick little thing about making sure that you know what your units are for your X values and plugging in accordingly here. Same thing happened with number 8. Same exact thing happens here. So you need to plug in 9.4 in for A, not 9.4 thousand. Plug in 2.5 in for B, and you should get this. Again, this is in terms of thousands right here. So 7 and 8, same exact issue. I think that's an easy solve there. Okay, let's go on to the next ones here. This one, I got an answer of 11 here. So what do we get? A regression analysis was performed to determine the relationship between TV hours watched and number of sit-ups can do. So the A value is important. A comes in as 28.612. The B value comes in as a negative 1.28. Okay, so you're going to write, if you're going to write that equation, you're going to write it like this. So 28.612 minus 1.28 times X. And what you're going to do is you're just going to put in a 14 and for that value, subtract from 28. You get a 10.692, round it off to a unit number or a whole number. You get 11, and 11 is going to be the answer right here, not 44. So the A and the B were the ones that were important. The R and the R squared was not important at all whatsoever. It was just there's just extra information. All right, chop that down. That's cool. Let's go on to the next ones here. Everything is correct. Okay, right at the end. So number 15 got a little issue here, right at 15. And so if you look at this here, everything's good. RO is 0. The alternative hypothesis is not equal 0, okay? And so if we look at this here, notice the p-value. So here's what you want to do. The p-value and the alpha value here is 0.2624, and the alpha value is 0.01. Which one's bigger? And you stated that the p-value is greater than alpha. That's perfect. Okay, so if the p-value is greater than alpha, what you have done is you do not reject HO. Since the p-value is greater than 0. Okay, and so if you do not reject HO, that means you're saying that there's not enough evidence to make a correlation between driving age and driver deaths. There's not enough correlation. So a few things here. We don't talk about negative or positive. We don't ever talk about negative, positive correlations because we're not even talking about it. So when we're over here, we're just saying, look, there's no difference. There is a difference. That's kind of what we're saying here. The null hypothesis does not look at direction per se of negative or positive correlation. So really the only difference here would be, do you have enough evidence to suggest that there is, or do you not? So because your p-value was greater than the alpha value, you don't have enough evidence to make that conclusion. Okay, hopefully that was good. Let's jam to the next one. 16. So let's go through these here. So this is, let's see, number of movies a person watches each year, the number of books they read. So as you look at it, you do have a negative correlation. But again, your hypothesis testing is not based upon negative or positive. It's just based upon the same or difference. Is there a difference there? So the p-value now is 0.0053. Okay, so p-value is smaller than that. The p-value is smaller than that. So therefore we say there is a statistical significance evidence to conclude that there is a correlation between the number of movies watched and the books per year. So again, regression line is useful at that point here. And we're comparing the hypothesis here. That's what we're doing. Okay. All right. And so remember the R squared value, it's really just this whole concept of having a reduction. And so for this one, R squared value is 64, which really just means that if you only look at people who watch a fixed number of movies per year, this variation is reduced by 64%. All right, looking at number or letter F here. This one was almost there. It should be a negative in there. Negative because if you go back over here, you get a negative correlation here. So it should have been negative 0.8. And if you look at a negative 0.8, and then you plug in a 5. After plugging a 5 into this little thing right here, let's see, 5 times 0.8 is 40, which would be a negative 40 or minus 4. That's what you have here. Minus 4 over here would get you a 2.89. Should be a 3 here. Let's see if that is correct. Yay, that is correct. Should be a 3 here at that point here. So there should have been a minus right here. Okay, so let's jam to this one here. So so real quick here, your answer was that if a person watches 0 movies, then they will read 7 books. And again, that is not what a linear regression line is all about. Regression is all about predictions. So the best prediction for a person who doesn't watch movies will be that they read 7 books a year. So that's the correct answer here. And that should be the same thing they get here right here. So again, linear regression lines are about predictions. If they are not, or if they are off the grid, or if they're on the line, values that are on the line. Okay, 17. Okay, I think we're almost at the end here, 17. So, okay, so value again, negative correlation here. Rho is, or p-value is 0. Okay, so we're saying that our alternative hypothesis, there is a change. We look at the p-value. We look at this one here, the p-value is very, very, very small compared to the alpha value. So if that's the case, there should be significant evidence to conclude that there is a correlation between those two pieces here. So again, we're just trying to figure out if there's enough for a correlation so that the regression line is useful for us. There's enough of a relationship there. And yes, there is. Okay, so E, same exact thing that we had before. So I think you're getting the same exact issues here. So for R squared value of 7.9 means there's a large variation, but if you look at the students only had a fixed number, and it should be reduced down for it. So it should be this one or this last one. Let's check. Yes, sirree. It is the last one right there. Boom. Okay. So let's see. And this one you got wrong as well. Actually, this one says round the answer to 1 decimal place. I think that's it right here. Notice it says round off to 1 decimal place. What you did is you round off to 2 decimal places, 1.32. And so because that, it gave you a wrong answer. I will give you that as a answer, in fact. G, let me go back over here. G, A, B, C, D, E, F. Let's see. A, B, C, D, E, F, G. This is what off a little bit. 1, 2. I know how to fix it. So this one right here, this one's going to get you 0.417. That should still be, that was pretty close. There's no need to get that wrong here. So interpret the y-intercept for the equations here. Okay, again, y-intercept is not a exact value. It's a prediction value. So it should be just prediction right there. The best prediction for GPA students is 3.57. Okay, so it seems like it's the same exact mistakes that you're having on here. First of all, is just plugging in into the thousands as opposed to values, but this one is just interpreting the p-values in response to your values there. Okay, so let's go with the p-value is equal to 0. P-value is not equal to 0. It is 0.01. We're looking at what relationship here? Okay, alpha is 0.05. So that means there's statistically significant evidence to conclude, yes, there is some kind of correlation between the values here because p is very small. That means our prediction value is useful. And so that's cool. Got that one correct. And let's see the R value here. And we're good there. All right, we made our regression line. That's perfect. And it looks like you plugged in well. So interpretation of the context of this right here, again, it's a best prediction line. So it should be the third one down. The best prediction is you get that right there. Okay, so again, same exact thing here. The best prediction would have been right here. That's the best prediction value. And exactly the same here. The best prediction, that's what we're looking at. Best prediction for game is, so I think that's it. Besides those little few things here, you did great. I'm going to save changes. And wish you well on the final.